Today we're going to talk about isotherms, which are patterns of temperatures drawn on a weather map, and weather fronts. So first up, defining what an isotherm is, it's a line that represents similar temperatures drawn on a weather map. And I'm going to give you an example and kind of show you how it's made in just a little bit. So a couple things you need to know about isotherm lines is that they go up and down in 10-degree Fahrenheit increments. So you might have an isotherm line for 20 degrees if that's kind of the lowest temperature range on a map for a given day. And then your next one after that would be 30 degrees and 40 degrees and 50 degrees. And they always fall on those tens. You also, it's kind of best practice to label each end of that line. So if you have a line on a map, maybe come in from the top and then it leaves out the left-hand side, you label both ends of that line just as a reminder what that line actually represents. There are some times where you have maybe some especially cold or hot temperatures that kind of reside near the middle of the map and you can't get a line that starts or ends on the edge of the map, then you may have to do a bubble or a circle. And in that case, you would just need, because that line would overlap on itself, you would just need one temperature or isotherm label. The information that we would use for central Wisconsin come from our two national weather stations, which are located in Green Bay in the eastern part of the state, and then down in Madison, kind of in the south central part of Wisconsin. So like I mentioned before, a couple reminders when you're drawing isotherms. You're going to add color eventually as well. So you would choose a different color for these different temperature bands. Normally I recommend warmer colors like your reds, oranges, and yellows, maybe pinks for your warmer temperatures, and then your cooler colors like blues and greens and aquas and things like that for your cooler temperatures. You're also going to be separating different temperatures with those different colors. Start those lines as much as possible on the edges of the map just so they're easier to see, and then you label both sides of those isotherm lines. So I have an example map here, but it actually is going to be a little easier if I show you on this map here. So we have kind of the Midwest United States here. We have all different temperatures here. You can see some temperatures down in the 30s and the 40s, 50s, 60s, 70s, and even a couple 80s it looks like in those areas. So I would start either with your highest band of temperatures or your lowest band of temperatures. And in this case, I'm just going to decide to start with the lowest band of temperatures. So we have temperatures down in the 30s. But the first temperature that shows up that's on the tens, because remember we always start in bands of tens, is 40. I don't see, unless I'm missing something here, I don't see any temperature readings with a 30 designation or a 30, but I do see some 40s. So here's what I'm going to do. I have a kind of a clear separation here. I have a 38 and a 49. That's a pretty big gap in temperature. So I'm going to take this pencil and I'm going to draw in and separate these temperatures here. And while I'm doing that, I'm going to do my best. Might make a mistake, but that's okay. This is just practice. I'm going to go through all the 40s because that's really what this line is representing, is the 40 line. So I'm going to keep temperatures that are more than 40 on one side and temperatures that are less than 40 on the other side. At least that's my goal. So we'll see if I can do that. So I'll keep those 30s above the line. It's just kind of working out that way. And then the 41 and higher go below the line. Okay, go like that. All right. Now, on this practice map, I can kind of see how close I got with that. So I'm going to draw right down here. It says 40-degree contour. It also has 50, 60, 70, and 80. I'm going to draw the computer's version of that 40-degree isotherm and see how close I got to it. I'd say that's pretty good for a first attempt. And you can see here it did a little better job here labeling the 40-degree mark over here and the 40-degree mark over here. So then we could do the same thing for the 50s. Right here might be a good spot to start with that. And I'm doing my best to keep the numbers that are less than 50 on one side of the line and temperatures that are more than 50 on the other side of the line. And my other task is to go through any of the 50s that I do see. So sometimes it's easy, sometimes it's a little trickier, but you just do the best you can. I recommend you do this in pencil, just in case you make any little mistakes. So you can change this to 50 and see what that looks like. And your teacher will have this practice set of isotherm practice map linked somewhere for you so that you can practice hopefully on your iPad as well. All right, so that's how you do it. If I took the time to mark the rest of these out, this is what it would look like. You can see we have a little kind of bubble of 80s right in here. So that one, you probably could have made it work if you started off the map and just kept going. But this one they decided just to bubble it in because it's just kind of a different set of warmer air in this region here surrounded by slightly cooler air. So they just did the bubble and labeled it 80 for that one. And then when you go back and you choose your colors, then you have an isotherm map. So that's what it is, just lines separating areas of cooler temperatures from warmer temperatures. And while doing that, they also go through the temperatures that match up with those 10-degree increments. So you have a 40 line, 50 line, 60 line, 70 line, and then you have one 80 kind of circle or bubble there. And then you colorize it, and that's your isotherm map. That's really all there is to it. Now, what this can help you identify is different types of weather fronts. So you have warm fronts, cold fronts, and then stationary fronts, as you can see here. So typically, a warm front is defined as a mass of warm air coming in and replacing cooler air. Remember, this is always going to be relative. So it's warmer air than is currently in that area, and it's replacing cooler air. Cold front is just the opposite. It's where a mass of colder air comes in and replaces warmer air. So again, relative. So if this happens in the winter, that warm air up here, that warm front might be a mass of maybe 30-degree air replacing 10-degree air. And in the summer, a cold front very well could be 50-degree air coming in and replacing 70-degree air. So again, it's always relative. It depends the temperature of the air coming in versus the air that is being moved out. A stationary front is a little bit unique, and because of certain atmospheric conditions, you may have warm air and cold air that kind of meet and they get hung up, or they don't really have anything motivating them to move one or the other out of the way. So for a period of time, it could be a day, it could be multiple days, they stay stationary, hence the name stationary front. Basically, where two different types of hot and or cold air meet, and they interact with one another along that boundary, and they just don't move for a period of time due to atmospheric conditions being the way they are. All right.